Hello and welcome to the first edition of the HbbTV webinar series in 2025. We've got a great topic for you, a technical topic. And when I was preparing that, I was thinking like, oh, I don't know whether there's so much interest in it. And still there is. 176 people have registered for this session to watch this session live. So reflecting your great interest in that, and of course the great speakers that we're having today. I'm going to introduce them in a minute. It's HbbTV and WebAssembly, unlocking new possibilities, the topic of our presentations today. And as usual, following the presentations, we've got about 10-15 minutes of Q&A for you to send your questions to our speakers. And we've got the best experts here for you for this excellent topic. And I've heard in the market already there is a lot of talk about this webinar because really it shows you some more excellent capabilities of what you can do with HbbTV. Once again, as usual, the presentations represent the views of the presenters and the companies, and not necessarily the views of the HbbTV Association. So that's enough of the formal stuff. So let's welcome the speakers. Today we have Stuart Harris, Chief Scientist from Red Badger from the UK. Also from the UK, Matt Hammond, Lead R&D Engineer from the BBC. Then we move over to Spain. We've got Rafael Bermudez-Gullo, Product Owner at the R&D team at 3CAT. That's a broadcaster from Catalonia. And once again, back to the UK, we have Matthew Huntington, Principal Consultant of Huntington Digital Consultants. Welcome to all of you. And let's get started now with Stuart and your presentation. Stuart, you're going to give a bit of an update on WebAssembly for everybody to make sure that we all understand what WebAssembly is all about and we're all on equal level, and then we're doing the deep dive. Thank you, Stu, and welcome to this panel.
Thank you. Great to be here. And thank you for the opportunity. I don't have presenter access, so I can't.
This will happen in a second, and there you go.
There we go. Fantastic. I'm going to share my entire screen, so I hope that's okay. Let me start here. So my job over the next 15 minutes, and I'll make sure I don't go over, is to introduce you to WebAssembly if you haven't heard of it or if you don't know much about it. It's a very whistle-stop tour. I've got two very quick demos because, you know, what is a talk without a demo, and the chances of them going wrong. So we'll get into it very quickly. I'm Stuart Harris. I'm a software engineer for almost 4 decades. My first job's in 1988. It's been around the block. Founder of Red Badger, which is a consultancy in London, and these are some of our clients, but this is not about Red Badger, it's about WebAssembly. So what is it? Well, it's not only web, and it's not WebAssembly. It's not assembly, sorry. It's more of a bytecode, just like Java bytecode or the Common Intermediate Language of .NET, which you're probably familiar with. But you could say that actually it's a binary instruction format for a stack-based virtual machine, which may not mean a lot, but it's effectively a portable bytecode, just like Java bytecode. So there's nothing much to it. The difference is that it's much simpler. So there's WebAssembly only has 4 types: 32 and 64-bit integers and floats. There's no baked-in object-oriented protocol kind of concepts like JVM, and it's not coupled. It's very independent. It's designed to be able to run without knowledge of where it's running, whether it's in a browser, out of a browser, whatever. It's very secure. So unlike the JVM, which has an allow by default process, this is like deny by default. So the sandbox it's designed effectively to run untrusted code in the browser, so safely. So the code can be written by anybody, anywhere. It's not allowed to perform side effects, and it needs the support of the platform around it, which is the browser initially, to do any real work, or to interact with the outside world, I should say. And it's designed to run code at native speed, and it's very lightweight. There's no runtime or garbage collector like there is with the JVM, and it's also designed to start very quickly, so it can actually start running before or start compiling the an incoming stream of bytes before the stream has ended, so that it's ready to go straight away. So it's very quick to start up. Very, very quickly, it's about decade old, and its history is with scripting, compiling C++, and C++ to JavaScript, and also after that ASM.js or ASM.js, which is a strict subset of JavaScript. It became very obvious that actually you could run compiled code quite quickly in the browser as a subset of JavaScript with like the little subset optimized quite heavily. And WebAssembly was kind of born out of that in 2015. By 2017, it was in all major browsers. And by 2019, the W3C had named it the fourth language of the web alongside HTML, JavaScript, and CSS. So that's the kind of WebAssembly thing. There is a 2.0 draft in the works. And then alongside of that, on top of WebAssembly, there's been a whole initiative over the last few years to build WebAssembly components, which are really, really interesting, and we'll have a look at those quite quickly in a minute. So first demo, what could go wrong? What is the simplest WebAssembly module we could create? So if I just make a directory HbbTV here and cd into that, then we've got nothing in here at all. So I'm going to open an editor and create like an add.wat. So wat is WebAssembly text, and the simplest. The reason I'm doing this demo is I kind of want to kind of demystify WebAssembly so that there is no, to see how simple it actually is. So this is a module. This is the simplest thing that can possibly run. It doesn't do anything. But I can create a function. AI is helping me here, which is very useful. A function called add, which I'm going to export. Well, actually, the function doesn't have a name, but anyway, I'm going to export this function under the name add. It takes two parameters, both of the named parameters. Both of them are 32-bit integers, and it returns a result 32. These are S expressions, by the way, so it's like a Lisp. The first line just gets X from the local environment, puts it on the stack. This gets Y from the local environment, which is this parameter, and puts that on the stack. And then we call i32 add, which takes the top two things off the stack, adds them together, and puts the result on the stack, and the function returns. That's it. It basically just adds two numbers. Remember, I said that we can only have i32 and i64, and f32 and f64. Those are the only things we can do. So if we want to run that, I can call add.wat and invoke the add function and add two numbers, 22 and 44, and I've got 66. So that is how simple WebAssembly actually is. It literally is that simple. So the interesting thing is that this is 122 bytes of text, right? So we don't normally deliver WebAssembly as text. So we can convert the WebAssembly text to WebAssembly. Now we have 41 bytes of binary bytecode, and we can call that in exactly the same way, and it does exactly the same thing. And this round trips, right? WASM and WAT round trippable, so I can actually convert the WASM to WAT and save its output as add2.wat, and now we've got two files, and the second one is almost exactly the same, right? So it's effectively, you can think of this as compilation and decompilation or whatever, to and from bytecode. This is exactly the same. It's a module. It declares a type, which is the first type in the module, which has a signature. Then it declares a function, which is the first function in this, and it's of type 0, has a signature, because that's our code. And then finally we export the add function. And add2.wat works exactly the same way as the others. So that's the first demo. Everything went well, which is brilliant. But just in case it didn't, I'll put it on the screen so we can see it. This is to demystify WebAssembly, right? It's very, very simple and straightforward. There was nothing massive to it at all. But the problem is we want the ability to be able to write any program in any language and compile it to a WebAssembly module, and we want to be able to run that WebAssembly module inside the browser, outside the browser, and on any platform, regardless of what architecture it is. This is what WebAssembly allows us to do. So how do we do that when we've just got numbers? And this is where the WebAssembly interface types and the WebAssembly component model come into it. So another very quick demo. I'm going to use a real programming language to create a WebAssembly module on macOS, and then we'll take that binary and we'll copy it to a Linux machine and run it there, which is a different operating system. Actually, same architecture because it's a Raspberry Pi underneath my desk, so it's also ARM, 64-bit ARM. But anyway, that's what we're going to do. So I'm going to use Rust because it's my favorite language. So if I create a new hello world, then we can see in our thing here that we've just got a simple Rust program that all it does is print hello world. And we can compile that using cargo build. CD into hello world and do that again. So now we've got a binary and we can run that binary, which is in target debug hello world, and we've got hello world. That's just a local binary, nothing to do with WebAssembly. The interesting thing is if we can target WebAssembly as a compile target because it's just a bytecode, right? So this is WASI P1, which is preview 1, which is WebAssembly modules. So now I've got a target in here and that has a hello world.wasm. So we can run that, or we can try and run it, right? But it won't run because we need a runtime to run it. We used WASM before, but we can use WASM time here. So this is a binary. I can run that and it says hello world. And if I HbbTV, compile it and run that hello HbbTV. This is a portable binary, right? So I can actually copy this hello world WASM to my Raspberry Pi underneath my desk. So that's now copied, and I can SSH onto that Raspberry Pi. This is one from earlier, but oh no, that's the one I copied, right? So now I can run that in WASM time on here, and I get the same thing. It's a portable binary, can work on any machine architecture and any operating system because it doesn't know where it's running or what it's running. It's completely platform independent. So that was the second demo. Also went well. Fantastic. This is a lightning tour. And that was just in case it all went wrong. So WebAssembly components. So this is where WebAssembly becomes really, really interesting because remember we said that it can't do anything on its own. It only takes integers and numbers and can't perform side effects. It relies on the platform, on the browser effectively to interact with the outside world. If it needs to make an API call, the browser has to do that for it. So what happens when we want to run WebAssembly outside the browser? We've got these WebAssembly components. So preview 1 was modules. We've just looked at that. Preview 2, WASI is the WebAssembly system interface, right? This is what the browser would do if it was running in the browser, but this is for out of the browser, and it allows us to build these components that we can write in any language. There's a canonical API. We can link them together into a single binary, either statically or dynamically at runtime. We've got capability-based security and generation of bindings, etc., so we can integrate them really, really easily. The really cool thing is that a component can't tell if the other side is a component or the host, so that means we can layer them and virtualize them. So if an inner component needs to access a file system, but there isn't a file system, an outer component can actually virtualize that and say, here's your file for you. And we've got this shared nothing architecture where each component has its own stack and its own memory heap. So on the left, we've got a component written in Rust, and on the right, written in Go, and they've both got their own stack, and they talk to each other over these well-known interfaces, which is the WebAssembly interface types. And then we can compose them into bigger components. So this is an outer component, which also has its own stack, and it also has its own interface, and that interface can be with a platform, or with anything or with another component. So that's what WebAssembly components are. And outside the browser, WebAssembly is starting to find its place as effectively a successor to Docker containers. And so, this is like platform evolution. We started with bare metal, we got VMs, we got containers which we run on Kubernetes, and now we've got WebAssembly, which we can run as components on platforms like Cosmonic's WASM Cloud or Fermi and Spin. There's quite a few platforms that allow us to run components natively in a scale to zero fashion. So this is WASM Cloud, and the reason I put this here is because it's quite interesting that because web components are just components and they're so lightweight, they can run anywhere, like on any edge, smart devices, IoT, etc., in the browser, on any platform, in any cloud, and they can communicate with each other. So we can build microservice applications, we can embed WebAssembly components in places effectively where Docker containers can't go. So very quickly, we're finishing now because I've got run out of time. We can build components, so we can just concentrate on the business logic. We push the side effects out to the edge and down into the platform. We can compose them together in any way, shape, or form. We can make bigger components from smaller components and run them anywhere. And we can scale them to zero with no cold start. So it's like serverless without this cold start problem, and build apps that span multiple clouds and edges, etc. So in summary, this is what WebAssembly is: a simple stack-based virtual machine designed for running untrusted code in the browser, but you can run it anywhere, and portable across all platforms and clouds and architectures and machines and operating systems. That's it. I'm going to stop sharing.
All right.
If there's any questions, we can answer them at the end.
Thank you very much for this introduction into WebAssembly. It's not as complex as I thought. Even me as a non-technician understood the basics, so well done. By the way, before we move on to the next speaker, a quick reminder, please do send us your questions through the question tab in the tool we're using here for this webinar session, and we're happy to respond to them after the presentations. So let's move on now to the next speaker. There should be Matt Hammond from the BBC now back on, so please switch on your camera. Excellent, there you are. And I'll quickly turn you into the presenter, and then we can see your presentation. Thank you, Matt, and welcome to the virtual stage.
Thank you. You can see the presentation?
Yes, it's there.
Great.
Thank you.
Thanks. So yes, I'm Matt Hammond. I'm a lead R&D engineer at the BBC's Research and Development Department. Obviously, the BBC's been a big user of HbbTV for many of its services, including iPlayer, for many years now. And in R&D, we've been heavily involved in the development and evolution of HbbTV. So I'm here to talk to you about the next version of the HbbTV spec. That'll be 2.0.5, and to give you a flavor of how WebAssembly is being included in that and how as a developer you might be able to target it. To build on what Stuart was saying, or my simplified picture of what Stuart was saying, is from a web perspective, you could say that, well, WebAssembly was first formally codified as a 1.0 specification by W3C around 2019, and as Stuart said, by that point it was already implemented in many browsers. And since then, it has actually continued to evolve. As was described, it's a byte machine, and so new features, new instructions have been added to that over time. And the WebAssembly community has done this through a process of developing what they call feature extensions. And the browsers have evolved to include these new bits of functionality, as has the specs themselves and also the compiler tooling. But this does create a challenge. WebAssembly is therefore a moving target. So applications that you build now, using the latest compiler tools that you can download may rely on or potentially utilize some of those new instruction set features in a WebAssembly runtime, and therefore might not work on an older browser. Now, in practice, for the browser on your desktop or laptop, this really isn't a problem because that's being very frequently updated proactively. But obviously, the TV market functions a bit differently, and a device will typically be in a user's home for many years. So from an HbbTV perspective, it was therefore important that we profile a set of features and we get a good balance between it being a relevant and up-to-date set of features, but also practical for manufacturers to target. But also the developers need to be able to target that as well. And a couple of things have happened just very recently, which have made that a lot easier for us. So at the end of 2024, a formal draft of 2.0 WebAssembly was published, and that effectively you could think of it as a snapshot that took 1.0 and bundled in a whole bunch of feature extensions that are already pretty mature and well implemented and have been implemented for some time. And the other thing was the WebAssembly community recognized that this would be a potential challenge and that developers needed a way to target a particular version of WebAssembly runtime, and therefore defined this concept called the Lime series, which, as you can see here from this quote, it's a stable and defined subset of features that promote interoperability. And the whole idea is that it's intended to be implemented by producers such as LLVM, so that's your compiler tools, using the concepts such as target CPUs that they already support. And critically, once a Lime configuration is defined, it'll be stable and not add or remove any features. And the very first configuration was defined at the end of last year, Lime 1. So when it comes to the next version of HbbTV 2.0.5, I'm really pleased to say that I think we've agreed that it will be aligned with Lime 1. So in practice, that means that if a TV is fully supporting HbbTV 2.05, then it's going to include support for the features in WebAssembly 2.0. So that means the core and the JavaScript API and the Web API specifications that W3C publish. And also there was one extra feature, the extended constant expressions feature, which in practice has been stable for some time as well. And down at the bottom, you can see I've got a little list of what those features were that were developed since 1.0 and that have been bundled into 2.0. So to give you a sense of what that means in terms of how up to date it is, I went and had a look at what browser versions supported this set of features. And as you can see, the likes of Chrome and Firefox, we're talking about April and May 2023. So actually, I think we've done pretty well here. This is a good set of relatively up-to-date functionality. And also, building on what Stuart said, the point being that WebAssembly code doesn't just have to run in your browser, it can run in many other places. My last example on the list there is Node.js, which since version 21, which was October 2023, that also supports the same set of features. So code that's built to target the Lime 1 profile could run on any of those platforms. So yes, as a developer trying to target it, well, using tools like Inscriptum and LLVM, you can simply specify the target CPU. So in this case, it will be saying Lime 1. I think support for that, because this is a relatively new concept, it was only just very recently added to LLVM, I think version 20.1 and later. So maybe the tools you're using now, if you're already trying WebAssembly, won't support that yet. In which case, MVP is a pretty good choice of target right now. But of course, that one isn't guaranteed to be stable, so do switch to using Lime 1 as soon as your tools are updated to support it. Now, of course, that doesn't cover everything that's in there. Some features of WebAssembly, such as SIMD instructions that help support things like media data processing, these are things that you do need to turn on separately. And of course, your source code needs to actually make use of these as well. So that might be having actual dedicated use of SIMD instructions in your code, or maybe in your compiler tools, turning on optimization features such as auto vectorization. And of course, there's documentation out there that tells you what you can do, how you can do those things. Finally, a word of caution, certainly from my own personal experience of trying out tools like Inscriptum. It's a fantastic tool, but it can sometimes try and be, in my experience, a little too helpful. These tools can sometimes detect what your code is what your code might try and use in terms of functionality, and may enable some of these features themselves. One example we came across was threads. It's often a good idea to double check what your tool is producing in terms of your WebAssembly binary. And yeah, tools such as WASM opt can help you check what features are used by running that over the binary that's been produced and seeing effectively what instructions it's asking the virtual machine to support. So finally, just to give you a sense of how soon you can see these capabilities in TVs, well, actually, a lot of devices out there in the market now already support WebAssembly to some degree. That said, they may not support the full set of features we've talked about here. So perhaps if you do want to try stuff out now, you may want to make use of feature detection code. And Google, for example, have published a library that does some basic feature detection. The HbbTV specification is very close to being finalized now, and I would personally expect it to be published sometime a little later this year. In terms of when TVs will support that full set of functionality, well, obviously manufacturers work on a yearly cycle. They're always updating their browser engines that their HbbTV implementations are based on. So perhaps even as early as next year, you will see more and more TVs out there supporting the same set of features of WebAssembly that we've talked about here. That said, obviously support for the full set of features that will be in HbbTV 2.05 and coverage of that in HbbTV's test suite, that will take a little bit longer. So maybe you'd have to wait till 2027 or later for that. But yeah, it's really exciting. It's technology that's kind of already starting to creep in there already, and we'll be in a position where we have a pretty good up-to-date set of functionality that we can guarantee will be supported in devices in the near future, which I think is a really great place to be in. So thank you very much.
Thank you very much for these insights on WebAssembly and the upcoming integration into the new version of HbbTV 2.05. Once again, quick reminder, first questions have arrived already. Please do post your questions through the toolbox, and we're happily responding in the Q&A section. Now let's move on to Catalonia, where Rafael is waiting for us from 3CAT, and we're very keen on hearing from you what you're doing with WebAssembly and HbbTV over there. I'll quickly turn you into presenter, and you should be able to share your screen now.
Yes.
There it is. You also have audio and video for us. And
only video. No, it's not important.
Okay.
Okay.
And there it is already.
Okay.
Thank you.
Let's start by the beginning. I'm Rafa Bermúdez from 3CAT. We are the Catalonian broadcaster. I'm pro owner on the research team, and I want to share our travel discovering WebAssembly and also trying to improve accessibility service using WebAssembly. We are going to share two POCs, enhancing subtitles and enhancing sign language. Let's start by the why. Why accessibility needs WebAssembly? Let me raise the question. Why do you think, why does accessibility need WebAssembly? We will back to this question at the end of the presentation. Maybe because it's cool, because we need to perform CPU intense tasks, because we need to perform CPU time constraint tasks, or maybe all of the above. So why we need WebAssembly and accessibility? Because we want that everything should be synchronized, not only video and audio that we used to complain when we don't have synchronization between audio and video, but it's also important to have the sign language and subtitles synchronized with the audio, because we are doing an audio to visual sensory substitution. We are providing to the user, the hard to hearing user, we are providing an alternative in the video. So this alternative must to be synchronized with the video that we are providing. So having said that, let's jump to the first POC, subtitling with WebAssembly. We had created some years ago, I think that 7 years ago, we create a library to parse HbbTV with a plain JavaScript, and we share it in GitHub. If you want, you can go there. This library was really cool because in that moment we didn't have TVs were not available to play natively HbbTV. So this is the only way to do. We did that on with plain JavaScript, and this is the result. It runs on all devices, and in high-end devices run really good, but in low-end devices the user experience was poor because subtitles could go out of sync. The CPU was too slow to synchronize with the video, and sometimes some subtitles overlap. So we took that project 1 year ago. We took that project and we thought it would be a good idea to translate it to WebAssembly and test it. So, and does it make sense to translate that library to WebAssembly? I think that yes, because when you parse a big subtitles file, you are consuming a you are consuming a high CPU resources, and you also need a precise timing for displaying subtitles in the right time code. So we took that library and we translated to Rust. We rewrite. I said we because I did it with my colleague ChatGPT. We translate it to Rust and we compile it to WebAssembly. Um, let me say that translate to Rust, it is valuable by itself because you will have a better memory management language. You will have also a better error handling language, and if it's your case as me, you are going to use a static typing that I would prefer over dynamic typing. So let me show you the result. We test it on a desktop. And at the left-hand side, you are going to see the subtitles rendered by by JavaScript, and the right-hand side, you are going to see the subtitles rendered with WASM. And at the end of the video, I will show the elapsed time taken by JavaScript and the elapsed time taken by WebAssembly. And we are adding the parts, the parts of the whole XML, the HbbTV file, and also the time that we take to render the subtitle into the screen. And this is the improvement, 75%. Crazy. This is a table with the summary. The HbbTV parsing, we have an improvement roughly than 50%, and for subtitle rendering, we have an improvement of 62%. So as Matt said, it ran on some TVs. We have some TVs that support now WebAssembly. So we throw it on to a TV, and I'm going to show the results. Is the same case. You are seeing at the left Pure.js, at the right WASM, and the improvement was little higher, 85% of improvement. And this is the summary table. The mean time taken by JavaScript for HbbTV parsing, we are parsing a 1 hour video, a 1 hour subtitles, 1 hour with 1 hour of video of the subtitles, and the improvement was 86%. That it's really crazy because you are winning a lot of time to do whatever you want or to go faster to the video. And for the subtitle rendering, you are the improvement is 72%. It's really, really high. And I think that you are going to reach all devices. You are not going to have problems with low-end devices. So the next step for subtitles, so far none. This is only a technical demonstration. We actually believe in native subtitling, and the interpretive task force, this is only for technical demonstration. So let's jump to the next POC. Sign language with WebAssembly. High hopes. What is the best sign language service? The best way to integrate sign language is by playing a second video, right? But with only one decoder available in HbbTV, the second video must use software decoding. So WebAssembly can do that. You will have a high CPU consumption when decoding each frame. We don't know if we can do if our devices can do that. I will show you later. You are going to have also a strict timing requirement to maintain a frame rate, a constant frame rate. And you can leverage existing codecs writing in low-level languages like lib H.264 or H.265. So let me show one example. 1 year ago, after a very short conversation with John Pising about the capabilities of WebAssembly, I started to went through all the internet trying to find a player that plays WebAssembly, that plays video with WebAssembly. I found a player that play OGB with WebAssembly. So I trade in a TV. I add 4 elements, 4 OGB videos playing at the same time with the DTT at the background. Playing smoothly. And this is not the high-end device. So it seems that WebAssembly can do that. So let's jump to the next demo. I prepared that demo for Plugfest Berlin 2024. What happened here? It should be a video. Well, no problem. Can jump to the next one. Well, this video does not work, but you can imagine that here we have the WebAssembly software decode video, and here we have a content playing. We run it on 7 devices on Berlin Plugfest, and we only detect one device with some issues. Some issues is that we are not playing the video at constant bit rate, or the colors of the video wasn't right. So for the Plugfest 2025, we prepare that. We have we are software decoding H.264 video, and we are displaying the dropped frames, the frames that we are trying to reach 25 frames per second, but if we can't reach it, we drop frame and continue. So the results. This is the video characteristics. The format was an MP4, the codec H.264, a profile of the H.264 was baseline. The resolution that we choose was 400 by 500, the bitrate 300 kilobytes per second, and we tested in 9 devices, and we detect only one device with a lot of drops, and the other devices, well, I think I can show you it working. And in that devices, it was perfect in 5 devices, and in 3 devices was with some drop, but the user experience was quite good. So we also wanted to test an H.265. If it works, yeah. And we made the same codec H.265, all the same properties, and we detect that we at with H.264 we have 5 devices with 0 drops. In H.265 we have 3 devices with 0 drops. As you can imagine, H.265 is a little more CPU consuming, so it's normal that we detect that this that the performance go a little lower. But this is no problem because in that case we are thinking that for sign language you don't need you don't have problem with the bandwidth because you have all the bandwidth that you want. If you can go, you can even go to a maybe a in picture video, if it makes sense. So the last demo that we did for Plugfest 2025 was testing with Dash. We didn't build a Dash player. We only stitch some segments in order to check if it works. It can work, and but we didn't make all the Dash implementation because we don't want to reinvent the wheel. We want to use Dash.js or other Dash player. We only want to change the render system. So in that case, we detect that it was perfect in 6 devices. In in 3 devices we have some drops, and none of the devices have a lot of drops, and none of the devices does not run. So it seems that we have a very good solution to put in production in some day. So next step for sign language. First of all, find a way to connect to Dash.js. We don't want to reinvent the wheel, just replace the rendering element from video to canvas with WebAssembly. Define the minimum acceptable video quality, frame rate, delay, etc. We want to work on this with real users. We want to make surveys with real users. We also want to synchronize with DTT stream using TEMI signaling, and we need to test it on real devices. Let's go back to why does accessibility need WebAssembly? I will say that it's because it's cool, because we need to perform CPU intent, because we need to perform time constraints. So the right answer was all of the above. The last slide, conclusions. WebAssembly could help us improve our services, especially on low-end devices, as we have seen for the subtitles. WebAssembly will will enable us to create amazing new services as sign language, and you can start now, as Matt said, but with caution. Please do not reinvent the wheel. Please only use WebAssembly when makes sense. Some devices in the market already support WebAssembly. And thank you for your attention. That's all from my side.
All right, thank you very much for these insights, especially on accessibility features. And now let's move on to Matthew for the next very brief session of insights, but very briefly because we have received virtually hundreds of questions. So let's make sure there is enough time for responses. Over to you, Matthew.
So what I was going to do was just kind of wrap this up by looking a little bit beyond what we've seen today about what the use cases of WebAssembly and HbbTV might be. And so, what we've seen is subtitling, and what Raphael was showing us is how we can do software video decode to create a different experience, and in this case, to enable accessibility. And I think that's a really great use of the technology. Accessibility, very important subject. But what else could we do with video decode? So one sort of thing, if we look back at what people have done with lots of video decode, sport and multi-camera angle is quite often a use case that people have done. So we could create experiences where, if I take the example of Formula One here, where you can pick your driver, and then within the HbbTV environment, you're picking which drivers you want to see during the match, taking advantage of in-car cameras. Formula One's not the only sport. Golf is another example where you have lots of action happening at the same time that you may want to track. Another classic is tennis. You may not be aware that Wimbledon, we have here in London, they have 18 matches playing at the same time across the courts. And if you look there, you can see the crowds across those 18 matches. And another classic example is the Olympics. Back in the day when the rights were less controlled, the BBC had 14 live events being played out. If you want to kind of watch one while waiting to see whether action is taking place in another, so you can switch between them, you need that kind of video mosaic approach, and you want flexibility, which that will give you. But it's not just about sport. Other events have multi-camera angles. If I take Glastonbury here in the UK, there are tens and tens of stages, but there are 10 main stages that you might want to watch. So, you know, look at a new band on the acoustic stage while you're waiting for the big headliner to hit the pyramid stage. But what else? What else is there? Well, another use of WebAssembly, WASM, as it's sometimes called, that's how you pronounce that acronym, has been games engines. So what powers most of the games that people play on consoles are these game engines, and actually the game engines have been ported to WebAssembly. Now, I'm not actually suggesting that we start playing Fortnite in HbbTV. People will do that on other devices, but there are some interesting things that WASM could do with games engines or others within gaming. But actually, when I was thinking about game engines, I was thinking about something else, because they're not just used for games, they're also used for virtual reality. So when people are creating virtual reality worlds, they're quite often doing that with game engines. Now, I'm not thinking that Second Life can have a second life through HbbTV. I was actually thinking more of volumetric video. So as people create volumetric video experiences, they're using game engines to render those experiences, both in the polygons that need to be created, and then the video decode that goes onto those polygons. And that's very processor intensive, and WebAssembly could bring that to HbbTV, to television experiences, without a vast amount of standardization needing to go into volumetric video for them to be natively supported in televisions. Yes, VR is for headsets, but people do show VR on our 2D screens, but allow people to use their remote control to change their viewpoint and see different places. And anything else to wrap this up? Well, there's another area which is around security, and there's a technology called white box cryptography, which is where you have unprotected environments. There's no hidden secrets, and the keys that are needed to make security are then obfuscated within the actual code. And this is something you can do with WebAssembly, with the compiled code. You can go hide keys in that. And this enables us to do different security things that we can't natively get from a television. For instance, you could support different DRMs to the one that a TV supports, if that was a useful use case. May not be. And then my last thoughts on this is really the innovation will come from developers experimenting with technology. And so what we wanted to do with this webinar, we're a bit early because 205 has not been published yet, but we wanted to get people thinking about this and thinking creatively. And just the advert I would give as the manager of the HbbTV developer program is that we're trying to improve resources for the development community to help them innovate. There's our developer portal website full of resources for them, and also a Slack community available as well for developers to connect into, and those are QR codes for that. And that is what I was going to bring to an end on the talky bit of this presentation.
All right, thank you very much, Matthew. To round this up, and I'd like to welcome all the other speakers back to the stage. So please switch on your cameras and your microphones, and here we are now, the full set of speakers. I'll quickly share the screen, and we have, as I said, received virtually hundreds of questions. I've tried to go through them while the presentations were running and identified, I hope, the most relevant ones to the general audience. First of all, a quick comment. There are several blogs on Red Badger's blog site that give you a deep dive introduction to programming in WebAssembly text. So you can see the URL on the screen here now. And by the way, all these presentations will be made available to you after this webinar and sent to you by email, and also be made available on the HbbTV website. And that also answers the last question referring to the Slack community. Yes, on the Slack community as well, and Matthew is going to handle that, of course. A question to Stuart. I'm an old C supporter. Which is the difference between WebAssembly and C?
Yeah, very, very quickly. So C is a programming language. WebAssembly is effectively a bytecode. Anything. So it's polyglot, any language. It's deliberately doesn't have any opinions about what language compiles to WebAssembly. Pretty much anything that works with a stack-based virtual machine. C is a great candidate, and Scripton is a great compiler of C for WebAssembly. Yeah, I mean, use any language. C is great.
Okay.
And
then now a question that several people have addressed to Stuart and Matt, and then for Raphael: how big does WebAssembly impact the required memory on a TV? And for Raphael, have you profiled the browser memory available required to support video decoding and rendering? So general question, how much memory is required to run WebAssembly on TV sets?
I'll go very quickly. Sorry to jump in, but WebAssembly, the runtime is actually very, very small because the overhead is almost minimal. There is no garbage collector. There's no runtime in WebAssembly, so it doesn't need much memory overhead. If you use a language that compiles and is very memory efficient, like C or Rust or C++, then you're going to get better results than if you compile a managed library like Java or Kotlin or Go or JavaScript or any of those that need a runtime, because you're going to have to compile the runtime in there as well, so the memory overhead will be bigger.
I think I very much echo that. The certainly from what things we've looked at, and perhaps Raphael will confirm this as well, it's actually your application's need for memory that's probably the biggest contributor, particularly if you're doing things like processing images. That's where most of the memory is going to go, rather than overheads of the WebAssembly runtime.
Okay, let's stay with you, Matt.
Well,
WebAssembly looks very interesting.
So I think
or Raphael?
we should get Raphael's answer to the actual memory question here, because there's a
let me add that we have taking into account all the buffers and all that kind of thing. I think that for decoding that kind of video, it's a small video, 300 kilobits and low resolution. It's more or less 50 megabytes or 20, more or less, into 50-20.
Okay. Anything to add, Matthew?
No, so when it comes to video decoding, you can kind of work it out, because the most memory intensive thing is your uncompressed frames. So that's how you can kind of work out if the amount of memory you're going to need is going to be a factor of how many uncompressed frames that you're showing on the screen. And it's that image size that ultimately is going to drive what the amount of memory you need to do something like video decode. And then it's going to be a multiple of that with all of the buffering and the actual decode process.
Okay, one to Matt. WebAssembly looks very interesting, in particular in the way of Java. However, WebAssembly may have many runtime implementers. It sounds to me TV sets may have a wide variety of execution performance. Do you consider the performance aspect into profiling?
Quite a bit to unpack there. So I think in practice, the implementations inside TVs are often part of the actual core browser implementation, and these are often these days based off things like Chromium, for example, and Chromium's V8 runtime engine. So the implementations are pretty mature and well developed, and the same core implementations that have come from the desktop browser space, which I think is really good. In terms of performance, yes, absolutely, it is going to vary, and that's often an area in which manufacturers differentiate at different price points. So it's not necessarily something that HbbTV can profile, at least not at the moment. But yeah, I think implementations are generally going to be pretty good, because there's not necessarily as much variety as you might fear.
Okay, next one. Apologies. Can I do what WebAssembly feature detection at runtime on device and use a fallback to pure JS if a feature is detected as missing?
Absolutely, I think you can. I think, as I mentioned in my slides, the likes of Google have published an open source library that does feature detection across all the different feature extensions that have been developed for WebAssembly. So you can, in principle, have a fairly lightweight piece of code that actually probes a television and checks what functionality is supported.
Okay, in the context of HbbTV, what's a real life example where you ditch JS in favor of WebAssembly?
So I think what
Tricky.
I was doing there in my piece is really looking at those use cases where the things I was pointing at you just can't do in a TV and in JavaScript. So video decode, game engine rendering of polygons, white box cryptography. These are example things you couldn't do. The question is then, do they create compelling use cases? I think we saw with Raphael that accessibility is a compelling use case for software video decode.
Okay, I think that's a good example. Next one to Matt. Is there a way to understand from an application which WebAssembly functionalities are already available on a terminal before 2026?
I think feature detection again, easy answer there.
Okay. Next one also for you, Matt. Is the BBC currently using WebAssembly in production? If so, what for?
As best as I understand, I don't think we are at the moment, but we're always actively looking at these things. I can't speak for my colleagues who actually develop and run our day-to-day services like iPlayer. So take anything I say with a pinch of salt there.
Okay, another question for legacy devices. We work with older CTV devices, including old HbbTV spec devices running old browsers without WebAssembly support. What are our options to use WebAssembly on these older devices? There's also a question in chat whether WebAssembly is available on HbbTV 1.5.
I could probably answer the 1.5 question. That's pretty unlikely. I think 1.5 was based on browser engines that well predated the development of WebAssembly, so that's probably very unlikely.
And the other question regarding legacy devices?
So Stuart, in the history of WebAssembly, is there a point where people have been using effectively JavaScript runtimes to actually improve performance using compiled bytecode? And
Yeah,
whether that helps or
sorry.
not.
Yeah, no, I think the history is actually quite instructive because before WebAssembly was even a thing, as ASM.js, which is a strict subset of JavaScript, was actually quite a very highly performant. Surprised a lot of people about how performant it actually was, and they made some extra optimizations in the browser, for instance, to support that subset and make it even more performant. But 3D games like and game engines like Unity and Real, etc., were compiled to ASM.js and run fine in a browser. So yeah, I mean there are options. I mean it's still a thing. You can still do that.
Okay, let's quickly move on to get the rest of the questions done. What's the URL to WebAssembly HbbTV use cases again for 3CAT? I believe that's going to be in your presentation, which will be made available for download. Raphael, is that right?
Yeah.
Okay.
We will
Next
share the
question
presentation
for you as well. In which cases are you using HbbTV for subtitles instead of the built-in TV subtitles?
for all devices, for consuming VOD in all devices, MP when you're consuming MP4 in all devices, good performance all devices, indeed.
Okay. Question regarding the Plugfest London 2025. Do you have any profile of those 7 devices tested on HW64?
Profile, no, just the dropped frames. We cannot get the memory footprint and all that kind of thing, just the dropped frames. And
Another one
I will
for
share
you.
it in the presentation.
Exactly. So we're looking forward to the presentation then, which will be made available for download after this webinar on the HbbTV website. Another one for you, Raphael. On your perspective, what is the limit of resolution and bitrate of secondary sign language video to play it on a mid-range TV set without any degradation of the of any part of the services? So again, a question regarding the capabilities of TV sets?
Yeah, it depends the capability of the TV set. I would like to have some different adaptation set for different capabilities of the TVs. I mean, it will be really nice as if you can change the adaptation set when you have a low network quality. It will be really nice to change also the resolution when you have a low CPU availability. I mean,
Okay, last question. How about performance for exchange data between WebAssembly and JavaScript?
I think it's worth saying here that you don't have to serialize data across the boundary. When you instantiate a WebAssembly instance, you can create memory tables and you can share those between the host and the runtime, so you can actually literally pass a handle to some shared memory rather than having to copy that data across the boundary. So it's very efficient in that sense.
Thank you very much. And thank you to all the speakers. And there have been many more questions coming in through the question tool. Don't worry, the details to contact the speakers will be on the presentations, which will be made available pretty shortly. And I have a very last announcement to make exclusively now in this webinar live. And that is regarding the symposium this year, which is going to take place in Istanbul. And we now have confirmed the dates. It's on the 12th and 13th of November this year in Turkey. And as you can see, this bridge here is going to be a great bridge for HbbTV and all the community between Europe and Asia, symbolized here. And we're sure this will open up many opportunities for you to grow your business and have exciting experiences with this technology. Thank you very much again to all the speakers. Thanks for being part of this session. We look forward to the next one, and take care. Have a good day. Goodbye for now.
Thank you, Johan.
thank you very much. Have a nice day.
Bye.